This video I am going to show you how to make a simple LED flasher circuit, and then I'll explain you the role played by the individual components in controlling the flashing rate of the LED. So let's get started. The components you need are a 555 timer IC, a capacitor of capacitance 1 microfarad, an LED, 3 resistors of values 100 kilo ohms, 470 kilo ohms and 270 ohms, a power supply and a few breadboard connectors. If you are using a power supply of voltage greater than 9 volts, then you should use a resistor of 1 kilo ohms in place of 270 ohms for RL, or else the LED would burn out. Here I am using 4 AA batteries, so the voltage here is 6 volts. Now take the IC, observe the notch on top of the IC. This is to indicate the pin numbers. So when you place the IC such that the notch is on the top, the pin numbers start from here. Pin number 1, 2, 3, 4, 5, 6, 7 and 8. So place the IC in this position. So here the pin number 1 is here, 2, 3, 4, 5, 6, 7 and 8. 8 here. If you are new to breadboard, then note that all the 5 slots in a column are interconnected. Now if you observe the circuit diagram, you'll notice that pin numbers 2 and 6 are connected to each other. Pin numbers 4 and 8 are connected to each other. So in the first step, we'll be connecting the pins 2 and 6. So the pin 2 is here and the pin 6 is here. So we have to connect the pins 2 and 6. We have connected the pins 2 and 6. Now we'll be connecting the pins 4 and 8. The pin 4 is here and the pin 8 is here. Now we have connected the pins 4 and 8. Now we will connect the capacitor. The capacitor has to be connected between pins 2 or 6 and 1, which goes to the ground. So the ground is connected to pins 1 and the negative of capacitor. So we'll be connecting the negative of capacitor. You can see the symbol here to pin number 1 and the positive of capacitor to pin number 2. So the negative of capacitor to the pin number 1 of IC and the positive of capacitor to pin number 2. Now we will connect the resistor 100 kilo ohms, which is RA, between pin number 7 and pin number 8. RA between pin number 7 and pin number 8. So this is pin number 7 and pin number 8. Now we will connect RB between pin number 6 and pin number 7. RB is 470 kilo ohms. We have connected RB between pin number 7 and pin number 6. Now we have to connect the LED. The positive of LED is connected to pin number 3. Find out the negative terminal of LED by finding out the flat surface. So flat surface is on this side. So this will be the negative terminal and this will be the positive terminal. So the positive terminal of the LED has to be connected to pin number 3 of IC. Positive terminal of LED is connected to pin number 3 of IC, and the negative terminal of LED, I am placing it on the column next to the 4th terminal of IC on this column, so that I could connect the resistor from this column to the ground, that is pin number 1. Now I am connecting the resistor 270 ohms from pin number 1 of the IC to negative of the LED. So pin number 1 of the IC, pin number 1 of the IC to the negative of the LED. Now we are good with all the connections. We can connect the power supply. So the negative terminal, which is ground, goes to pin number 1. And the positive terminal goes to pin number 8. You could see the LED flashing at about 600 milliseconds. Now I'll explain you how this circuit works. Here the capacitor gets charged and discharged continuously, and the time for which it gets charged and discharged determines the flashing rate of the LED. I'll show you that by adding another capacitor in parallel to the previous capacitor. So the effective capacitance now is equal to 2 microfarad, and you can see that the flashing time of the LED has increased. You can observe the same from this formula, which indicates that the time for which LED is on is directly proportional to the capacitance. Same for load time and the total time. Now the capacitor gets discharged through the path RB and through pin 7. So if we reduce the value of RB, the capacitor gets discharged very fast. I'll show you that now. I am placing a resistor in parallel to RB, and you can see the flashing rate has increased and the flashing time has reduced. You can observe the same here. I have reduced the value of RB, and high time as well as low time gets reduced. And the same with RA. If I reduce the value of RA, the capacitor gets charged very quickly, and so the flashing rate increases. Thank you guys for watching this video, and do subscribe to my channel and check out my other videos.